All right, so let's take our knowledge of right triangles and actually solve some problems. And before we can do this, we need a little bit of terminology. So there are two ways that we are going to talk about this. We're going to talk about a person standing somewhere, say this is on a bluff far away, and a person is standing here. And they look straight over. Well, actually, that's not how that's going to work. Okay, let me erase this guy. Whoops, that's not what I want to do, because we use different terminology. Okay. There we go. Okay. So let's say somehow we've got a guy standing on top of this, and he looks down. He looks down here. And what he measures is this angle with the horizontal. This is called the angle of, it's got a few different names, but in your textbook, we call this the angle of declination. You're looking at, you measure the angle down from the horizontal. Now the other way you can do it, so let's make this guy red so that everything is, so he's standing right here. There's a platform, and he measures this way. The other thing that the other way these problems can be presented is you can have a person standing here and looking up, and they measure this angle, and this angle is called the angle of inclination. Sorry, you probably cannot read that. Inclination. Okay. So in all cases, generally what happens is you will be taking a measure of an angle looking up at a top from a certain distance away. And what we're usually trying to do is find the height. So let's just take a look at this problem. Oh, let's not do that. So suppose we've got a person walking in the forest and wants to know how tall a tree is. And maybe they've got a walking buddy and they have an argument about how tall the tree is. So what happens is this person walks 30 feet from the base of the tree. We've made a little sketch, and there's 30 feet. And maybe they take their cell phone, and believe it or not, your cell phone can do this, and they tip it up, and it measures, and it tells them that the angle to the top of the tree is 57 degrees. And what we are asked to find, because that's the problem, that's the question at hand, is the height of the tree. So what we have is a right triangle with theta, an angle known, and 30 feet, and we don't know this side here. This is what we're trying to find. So if we think about, and we know that theta equals 57 degrees. So our trigonometric relationships that are going to be relative here is a tangent, because we know that the tangent of theta is equal to the opposite, length of the side opposite divided by the length of the side adjacent. So that means tangent of 57 degrees equals h over 30. So we can multiply both sides of this equation by 30, and we find that the height of the tree equals 30 times the tangent of 57 degrees. Now that's not very helpful. It's accurate, but it's not very helpful because we really want to know in feet how tall that tree is. So I've opened up Desmos, and I want to make sure I'm in degrees, and I can just type in 30 and then functions and then tangent 57, and I find out that my tree is 46.20 feet tall. Put my calculator away for a while. Not so bad. All right, let's try another one. So ignore the picture for a minute, or the sketch. So just pretend that doesn't exist right now. We're going to walk through it. Let's read the words. A person standing on the roof of a 100-foot building is looking towards a skyscraper a few blocks away, wondering how tall it is. She measures the angle of declination from the roof of the building on which she is standing to the base of the skyscraper to be 20 degrees, and the angle of inclination to the top of the skyscraper to be 42 degrees. Okay, so this one's a little bit more tricky. Our person is standing here on this skyscraper, and it's a little bit more tricky because what don't we know? We don't know how far away that skyscraper is. But I've got two angles, and that means I've got two separate right triangles. So I'm going to outline one of them in green. What are my other choices? Blue. So this is one right triangle, okay? And this is my other right triangle, and notice they share a side, right? X is involved in both of them. Now, I want to make sure you understand where this 100 feet came from. So what we did in order to build these right triangles is we drew a horizontal straight across from the building on which our observer, is standing. And that means that this leg is 100 feet. And that's going to be important because that is going to let us find X. So let's work first with that lower right triangle. This one. Well, there we go. So I know that this is 20 degrees. And I know that this is 100. And I really want to find that. Okay. Well, and my right angle is here. So again, I'm going to remember that the tangent of any angle is equal to the length of the side opposite that angle divided by the length of the side adjacent to that angle, as long as we're dealing with one of the non-right angles in a right triangle. So that means that the tangent of 20 degrees is going to be equal to 100 over x. Now, I really want x, so x is equal to 100 divided by tangent 20 degrees. Again, I'm going to open up Desmos, and I'm going to take 100, come here, and divide it by tangent of 20 degrees, and let's make sure I'm in degrees, and I am. And that tells me my x is 274.75. Okay. I want to caution you about intermediate rounding. So you can see that I wrote down this number, but what you're going to notice is when I bring Desmos back, I'm actually going to give that a label. I'm going to actually call that A. I know I used X in my problem, but I'm going to call it A. And what I'm going to do is I'm going to use that whole value that Desmos gives me. There are a couple of different ways you can do it, but you want to be careful in especially in this class with intermediate rounding. We have reached the point in our mathematical work where that can become a problem. Okay, so now, what do I really want? Well, I really want to find the height of that building, but I've got to go through another step. I now know this x is 274.75. I can now use that to find this a. All right, let's use a different label in my Desmos. Let's use b. Okay. All right. So I can do that because I know now that I've got a different right triangle to work with. I am now going to be working with the upper right triangle, which looks like this. Right? And we know this side is 274.75. This is my unknown a, and this is 42 degrees. So again, using tangent, the tangent of 42 degrees is equal to a over 274.75, which means that a equals 274.75 times the tangent of 42 degrees. That is not one of my special known unit circle values. So I'll open up my calculator. And instead of the 274.75, I'm going to use b, because that's what I named that number. B times the tangent of 42 degrees is 274.38. And those are now feet. They're feet because my other links were in feet. But that's not actually what I want, is it? Because I want the height of my building. And h then is 100 plus my 274.38, which is 374.38 feet. And that is the height of my skyscraper. Okay, so that brings us to the end of this section and to the end of this chapter. I hope you've enjoyed this, getting to know about trigonometry and right triangles and learning our trigonometric functions and circles and how it all ties together. And reach out and let me know if you have any questions.